Hi, thanks for watching. I've had a tough time in the last few months, but I thought I'd make a short video, try and get back in the game. What you're looking at here is Mount St Helens eruption in 1980. And as you can see, the ash cloud is pretty much vertical, it's gone straight up. Then it gets caught with the wind and it starts heading east. And there's another image of the same thing. This is the ash cloud from Mount St Helens, and it covers a large area of the USA, and as you can see it's pretty much heading eastward. Now, I've got an issue with that. And my issue is there's supposed to be a spin at 1,000 miles an hour here, and it slows down as it gets up here to Washington. Now, the latitude of the UK is 55 degrees north, and Washington is 47 degrees north. So the Earth spins apparently at 1,000 miles an hour at the equator, but in the UK it's down to 650 miles an hour, which means it'd be even slower in Washington state, because that is at 47 degrees north. So my question would be, if the Earth is spinning in this direction, surely any smoke or ash would be going in this direction, the opposite of the spin. Right, so let's see what ChatGPT has to say. Why do they say the Earth rotates at 1,000 miles an hour? Who said that, and what did they use to measure it? The answer is, the Earth rotates on its axis at a speed of approximately 1,000 miles per hour at the equator. This rotation is what causes the apparent movement of the stars in the sky, as well as the change of the day and night. So this will be the same stars in the sky that apparently are travelling at the speed of light ever since the Big Bang. Yet, we can see the same stars night after night. The concept of the Earth rotating at high speed was first proposed by ancient Greek philosopher Aristarchus of Samos, a Greek guy I'm imagining, in the 3rd century BCE. However, it wasn't until the 16th century CE that Dutch astronomer and mathematician Tycho Brahe made precise measurements of the movements of the stars and planets, which confirmed the Earth's rotation. Today, we use a variety of tools, we'll call them scientists, including satellites and radar, to measure the Earth's rotation. Right. So diving a bit deeper with ChatGPT, why isn't the Earth spinning on videos taken from outer space, especially one from Apollo 11, as it's flying out of Earth's orbit? Which was the Earth? Why was the Earth not spinning on the footage? The answer: the Earth does spin on its axis, but the rotation of the Earth is not visible in videos taken from outer space, such as those from Apollo 11 mission, because the rotation of the Earth is relatively slow compared to the speed at which the spacecraft is moving away from the Earth. Additionally, the cameras used to capture the footage may have been specifically adjusted to minimize or eliminate any apparent rotation of the Earth in the images. So let's go a bit further. If the ISS is travelling at 17,500 miles per hour, why do we see no motion of the Earth spinning? The answer: when you observe videos or images taken from the International Space Station, it may appear as though the Earth is not spinning. However, this is due to a combination of factors. So you can read that if you like, and pause it, but it just gives you a lot of numbers and pseudoscience to explain it. Therefore, the apparent motion of the Earth's rotation is not easily noticeable in videos taken from the ISS. Then they go on to say, camera settings. Cameras used on ISS or other spacecraft are often adjusted to capture images with a fast shutter speed. This helps in capturing clear and detailed images, but it also tends to freeze the motion and minimize any apparent movement of the Earth. The short exposure time of the camera captures individual frames without blurring the Earth's rotation. And they've got image stabilization and So, while the Earth is indeed spinning, the combination of these factors makes the apparent motion of the Earth's rotation hardly noticeable in videos taken from space. However, time-lapse videos of long exposure images specifically created to showcase the Earth's rotation can provide a clearer demonstration of the Earth's spinning motion. We call them cartoons. So let's go to Bogota in Colombia. Right, so this is north, this is south, and we'll go to the airport. Right, so here's the airport in Bogota, which is almost, well, it's pretty close to the equator. So that's spinning in that direction at 1,000 miles an hour. And we're told, although it's a lie, but we're told that aircraft fly at 500 miles an hour. So, how do you land on an airfield that's coming towards you at 1,000 miles an hour? Or, if you're coming in from this direction, how do you keep up with it if it's spinning at 1,000 miles an hour? The only time an aircraft lands on a moving target is an aircraft carrier, and they say aircraft carriers do not stop during aircraft recovery or landings. The reason for this is airplanes will land more safely when flying at a relatively slow speed and also directly into the wind. The ship must move in order to place the wind running down the angled deck, so the airplane is flying into the headwind. Crosswinds are to be avoided if at all possible, since they can push a plane off target. A carrier is not a land-based airfield, so there is little room for error. Still, pilots know how to handle crosswinds, but a headwind is optimal. Right, so that being the case, why don't they mention the speed of the Earth's rotation with an aircraft carrier? Well, thanks for watching. Please comment and please hit the like button.